Hello students, I'm going to do a sample video for us right now. Usually when we have videos like this, the goal is just to figure out what is the answer to the problem. I'm less interested in that right now. We will solve this problem, but I'm more interested in the approach, the thought process that we're going to take to stay organized. So I have written a problem here. In full disclosure, this problem is a bit of a disaster. Okay, it is intentionally kind of cluttered, and our job is to have some strategies for how we pull out the important information here. So I want you to go ahead and pause and thoroughly read this. Okay, so you've now had a chance to thoroughly read this. The first thing we should do is we should figure out what exactly am I being asked to find. Now it happens to be the very last sentence here. Certainly in common word problems, it could be up front. It could be at the end, but it also could be in the middle. I want to highlight how many gallons of water will be used for this pool. There's probably an of that should be right there. So how many gallons of water should be used for this pool? Now, when I'm doing applied mathematics, I need my symbols, as in a V for volume, and I need my units. And a really good problem solver is going to keep all of that stuff really organized. And so my recommendation to you is to come down, put a V, that is commonly what we would use for volume, equals question mark. That indicates that this is the thing I'm trying to find. And then I'm going to write gallons. That is my reminder to self of the units that I need to be in right there. Gallons of water. Okay, so what else do I have in this problem? Okay, blueprints show 20 centimeters long, 10 wide, and 3 centimeters deep. Okay, I'm going to come up here and I'm going to put a little note to myself that collectively this could give me a volume. This is a length times a width times a height over here, which is going to be interesting information. So the construction crew has 7 members and are currently focused on constructing a 2-meter long diving board that rests 1.2 meters above the pool deck. Okay, I'm going to pass over this a little bit right now because at the moment I'm failing to see how that information is going to help me understand the volume of the pool itself. So let's put a pause on this before we get too excited and start writing down diving board length, 2 meters long, things like that. I'm trying to be really deliberate in what information I think is useful. The actual pool will be built to a scale where 1 centimeter represents 1.5 meters. This feels more in line up here with information that's going to be useful. This clearly is not the size of the pool, that's teeny tiny, but I think I'm going to need this. So let's write that out somewhere. Let's write down 1 cm is equal to 1.5 meters. Okay, you will notice that that is not a proper unit conversion. What I mean by that is a proper unit conversion that we're accustomed to is 100 cm is equal to 1 meter or something like that. So notice that this is specific to this particular problem. So I'm gonna write this down, and I'm trying to make sure that I don't perhaps accidentally go down this road just by confusing myself when I'm looking at my centimeters here. Okay, next, this looks super important to me, this 90% full. So maybe I'll even come over here and I'm going to say 90% full exclamation point. And that's going to remind me that I better not forget to take that into account as well. Okay, I'm coming back up here. I don't really care that there's 7 members of this thing and they're working on the diving board. So I don't want the 7. I don't think I want this 2-meter long diving board that rests 1.2 meters above the pool deck. So you can see that I'm starting to litter this up, and I'll see this a lot of times with my students, but they're starting to categorize the information according to its importance. So let's start doing some of our work. I have this length times width times height information. So my length times width, it says depth up here, but I'm just accustomed to an H. It's going to be 10 cm. Very important to write your units. This becomes a reminder for yourself. Oops, sorry, 20 cm for the first one, 10 cm for this guy, and then 3 cm here. So this is on the blueprint, of course, And now what we need to do is I need to get this into meters. Why is that? Let's take a peek here. If there are 264 gallons in 1 cubic meter, so 264 gallons is equal to 1 m cubed. All right, so let's get these guys and let's figure out the actual dimensions of my pool. This is where I need this piece of information that's right here. So I'm going to take each of these and I'm going to multiply them by 1.5, and I'm going to change the unit. So if I were being very systematic about my unit conversions here, I would start with the unit or the number that I'm actually given in the top left corner. And then remember, this is a big division symbol for unit conversions. This is a vertical line that's simply an organizational component so that I can write out my unit conversion. I am not going to use this. We would normally do that if I was simply just transferring from one unit to another. But I'm doing something that I'm going to call a scaling factor. And my scaling factor says this is equal to that. So I'm going to come down here and I'm going to say 1 cm because I know that I'm going to need my units to cancel. So I always start with going to the diagonal. And I'm going to go to the meters. And in this particular problem, it's 1.5 meters. So this guy is going to end up being 30 meters. Okay. And so I'll come up here and I'm going to write in 30 meters. I'm going to do the same process, but I don't think we need to write it out every time. 15 meters. This guy is going to be 4.5 meters. And so now I'm looking at the information that I have after I did my scaling. I know my goal is to get a volume up here, and so I'm going to do this mathematic. So this is going to be 2,025 cubic meters. Okay, so far so good, except that I need to be in gallons. And again, there's my reminder of that. So I'm going to come 2025 meters cubed. I'm going to do my unit conversion. I need to get rid of meters cubed, and I'm going to go to gallons, GAL, and then I'm going to search for my 264 gallons is 1 cubic meter. 264 gallons. Okay. You can see my little handy dandy calculator here. This is going to be 534,600. Okay. Meters cubed are canceling. Now I have gallon. All right, looks like I'm pretty darn close, but here's my reminder. I only need to put 90% of that, 90% full. And so let's go ahead and take this guy and I'm going to multiply it by 0.9. And so I'm showing my work here. I'm going to say 90% of that is going to be 481,140 gallons. And I wasn't prepared to do sig figs on this particular problem, but this would be a really good time to come in and look at our sig figs. So I'm going to pretend, you can see I'm modifying here. I'm going to pretend I had 2 sig figs. So just kind of humor me with that. And I'm going to say 480,000 gallons. Okay, again, this problem is less about coming up with this number. It's more about trying to help students understand the importance of writing units. There's a different world out there where whenever I'm certainly trying to grade work or something like that, I will see just like a 20 times a 10 times a 3 sitting there. And then perhaps that just gets thrown in to multiply by 0.9 or something like that. Writing the units, does not take you very long. It is not a good argument to say it slows you down. What it does is it helps you be better at analyzing problems. And so you should absolutely get in the habit of always writing your units when you're doing problems. All right, so you should have a lot of practice of these particular problems that you can do in the module. Good luck.